All right, guys. Hello again, and welcome to G Squared Academy, where excellence is epitomized. In today's video, what we're going to be looking at is paper 3. This is 2005, January 2005, and this is question 3. So we're going to work our way through this question, as you can see on the screen. So let me just get this a little bit bigger for you guys so you can see it a little bit more clearly. Okay, great. So it says here, account for each of the following sets of observations, right? Glucose solution is mixed with yeast at about 25 degrees Celsius and left for some time in a closed container. The pressure in the container builds up and the ethanol is produced. The same thing happens when the glucose solution is replaced with juices extracted from sugarcane, waste paper, potato, peelings, or grass. However, nothing happens when the reaction is carried out at 75 degrees Celsius. So your question was to account for the following observations. Basically, you're going to have to say why these things are occurring, and you want to justify these things, if you can, with equations for the most part. So your answer should include um, the process taking place. So we're going to take them one at a time. So here we go. The first thing is that this process is fermentation. In the first case where you have glucose mixed with the yeast, this is possibly going to be anaerobic fermentation, which is the breakdown of the glucose into ethanol and carbon dioxide by yeast. Yeast is a fungus which contains an enzyme called zymase, and this zymase is able to break down the glucose into ethanol and carbon dioxide. By the way, this is the process by which we make a lot of beers which is fermented. Anything which is fermented, generally speaking, this is the way that we make those things. Okay, so the process is fermentation. All right, so then now it says the role of yeast, and I just mentioned that yeast contains an enzyme called zymase, which of course aids in the breakdown of the glucose into carbon dioxide and ethanol. Okay, so now what causes the pressure to build up? I kept saying it. Carbon dioxide is a product of this reaction. So therefore, what we're expecting to occur is that the CO2, which is a gas, is going to build up the pressure in the sealed container. Because remember that they said the container was closed, right? And this occurred at 25 degrees Celsius. So what causes the pressure to build up would be CO2. A simple equation to show how the compounds present in the various plant extracts give rise to glucose. So we're going to look at that now. Okay, so here we are now. Here we are now with our equation. So look here, what we have here is a polymer, and this polymer breaks down to glucose. Remember that they were asking us to show how glucose is found in these substances. So you have your polymer, which is broken down through acid catalysis, and this process is hydrolysis, of course. So we're using water to break down the polymer, and this can occur in acidic media or in basic media. This is why you have the OH minus here, and this is supposed to be a 2 really. So one or the other may be used for that purpose. And of course, you're using water. So your polymers here are cellulose, starch, and sucrose. And basically what happens is that these substances are broken down to form glucose, which is then fermented, or which is then broken down by the zymase in the yeast to give you your carbon dioxide and your ethanol. So those are the processes which are occurring in there. So, and this is a simple equation to explain that. So where does your things come from? Your cellulose, if you go back to the question here, the cellulose is found in waste paper. We know cellulose is used to make paper. It's also found in grass. Remember, cellulose is not digested by humans. It's not broken down by humans. It's mostly used for dietary fiber. The potato peelings contain starch, and of course, the sugarcane contains sucrose. So these substances all contain, let's just say, dimers or polymers of glucose, which are then broken down by hydrolysis, right, to give you your glucose, which is then used in the polymer, which is then used to make your ethanol and your carbon dioxide. Okay, so now the next bit of business is to show, well, any other relevant equation. Of course, I'll just show you the equation for uh, fermentation, which is C6H12O6 um, breakdown in a little heat. We're just going to put that 25 degrees Celsius and we're going to put zymase there. And that produces C2H5OH plus CO2, which is a gas. Okay. So that's ethanol. C2H5OH is ethanol. And CO2, of course, is carbon dioxide. And of course, you can balance this equation very simply later on. Okay. So that's another equation that may be used. The final question in this section is the effect of temperature on the process occurring. So what impact? Because if you go back to the statement, it says, however, nothing happens when the reaction is carried out at 75 degrees Celsius. Now, the thing about it is that enzymes, and especially these enzymes, which are biological catalysts, they operate at what we call an optimum temperature. Usually, and it's strange that usually most of these are like 37 degrees Celsius, which is the same thing for humans, right? And so at 75 degrees Celsius, what happens is the enzyme structure breaks down. And so the enzyme becomes denatured and inactive as a result of that, meaning that it cannot carry out its function. So even though the enzyme is present at 75 degrees Celsius, it's not able to carry out its function. And therefore, it's not able to break down the glucose as it would normally do so. And so that's why nothing occurs at that temperature. Okay, so if you do all those things, 10 marks for you. Remember, it is quality versus quantity. So we're going to move on to part B. It says compound A is a gaseous hydrocarbon with a molecular form of C3H8. Compound A is generally unreactive, yet compound A is a good fuel. Also, it slowly decolorizes gaseous bromine in light, but there is no reaction with bromine in the dark. Okay, so the first thing that you need to do here, even without going to the question, right? And of course, it's still again account for each of the following observations. So first thing you want to do is identify C3H8, okay, based on its molecular formula, right? The number of carbons is 3 and the number of hydrogens is 8. Now, looking at that, the number of hydrogens is 2 times the number of carbons plus 2, which means that we could end up with a formula, a general formula for this of CnH2n plus 2, right? Because N was 3 and H was the number of hydrogens was 8. So 2 times 3 plus 2. So 8, C3H8, which makes this substance an alkane. So we have identified compound A as an alkane. So that's good. So now the next thing is to look at what's happening here. The class of hydrocarbons to which A belongs. So A, we have already identified that. It is a alkane. It's an alkane. Why is A generally unreactive? Well, the thing about it is that if we go to the structure of A, what we're going to recognize is that A, right? And I'm just going to draw the structure here. A is saturated, okay? And as a result of being totally saturated, it will undergo what we call substitution reaction. So you're going to have to replace hydrogens here in this structure for it to react. And these things usually occur in light, or some energy source has to be present for these things to occur. Okay. And so that's generally why it's unreactive. In this context, we're not going to get into deep about bond enthalpy and those things because this is CXE or CSEC rather. And so we're not going to get into all of the things about the energy of the bonds and the fact that it is non-polar and those sort of things, which also aids in its unreactivity. A lot of things which are reactive tend to be polar. They tend to have a negative section and a positive section. If you look at this molecule, it doesn't have anything which is negative or positive, really. It's just basically neutral. And so that affects its reactivity. Hence, it is highly unreactive. Okay? All right, so we press on. Okay, so that explains its unreactivity. The type of reaction A undergoes with bromine. And I did mention this before, right? If we go back, it is fully saturated. When we look at the structure of propane as it is fully saturated. So for it to react with bromine, you have to replace one of these hydrogens or two of these hydrogens, in which case it is a substitution reaction. So that's the type of reaction which occurs here. So that's substitution. Why A reacts with bromine in the presence of light but not in the dark. And I did also mention this already, right? A, which is propane here, right? It is fully saturated and the bonds have high energy pretty much for them to break. So for this species to react with anything, you need an energy input to break these bonds, which is light. In the dark, it does not occur because there's no energy, so to speak, in the dark. In the context of there's no radiative energy, there's no source of energy in the darkness, which would cause these bonds to break and even cause the bromine bonds to dissociate as well, to form the radicals which they would form, right? So there's no energy source in the dark, and that's pretty much what we're looking at here. Why is a good fuel? Now, if you think about fuels, the first thing you want to think about is how much energy they're producing, right? And that's the basic idea of fuels. Okay, so I have a fuel. Why is this thing a good fuel? Because when I burn it or when I use it as a fuel, it produces a lot of energy. And that's exactly what your answer there. Now, if you're speaking about in terms of using chemical or chemistry jargons or scientific jargons, you want to say that the enthalpy of combustion of propane is high. Okay, combustion reactions are generally exothermic, which means that overall they release heat into the surroundings, right? But for propane, the value for the enthalpy of combustion is high, which is why you would say that it is a good fuel. Okay, so we will press on as well here. It says any relevant chemical equation. So we can look at, in terms of equation, the bromination of C3H8. We can look at that one and we can just write a combustion equation for propane, right? So let me just get my pen here. So C3H8, right? C3H8 plus O2, that produces CO2 plus H2O. And this is a combustion reaction. So we just put a 3 there, we put a 4 there, and then now that is 6 and 4. That's how we put a 5 right there. That equation is balanced. And then now for our light reaction, so it's still C3H8, and we're going to react that with bromine, Br2. So what we're going to do is just replace one of the hydrogens there. So we're going to end up with C3H7 Br plus HBr. There you go, right? And so we end up with hydrogen bromide gas, which is a very nasty gas, to be honest. So we're going to end up with this halogenoalkane over here. So we have replaced one of the hydrogens here, and replace it with a bromine. Of course, it's a substitution reaction. So we end up with C3H7Br, and then the hydrogen which was lost combines with the other bromine to give HBr gas. Okay, and of course, this process can continue until all the hydrogens have been replaced by bromine, based on the mechanism. But for CXE purposes, CSEC purposes, if I say CSEC, I mean CXE, CSEC in this context. You don't need to know the mechanism for the reaction. All right, so guys, that is 2005 question 3, paper 3, question 3, January paper. This is the January 2005 paper 3, question 3. So look out for the other videos where I go through more paper 3 questions, hoping to help you guys. This is Gilly Gills and this is G Squared Academy. All the best.